Welcome to our channel, where we dive deep into the fascinating world of data versus information. Today's video focuses on the technical differences between these two fundamental concepts in computer science and information technology. To stay updated with our latest content, be sure to like this video and subscribe to our channel. Now, let's begin our comprehensive exploration of data and information. Data can be defined as raw, unprocessed facts and figures that, in isolation, lack context or meaning. In computer science, data is typically represented using binary code, a system consisting of two symbols, 0 and 1, called bits. These bits are combined in various sequences to represent more complex data types, such as integers, floating point numbers, and characters. Data can be further classified into various categories, such as structured data, data that is organized into a specific format, often using tables with rows and columns. Examples include relational databases and spreadsheets. Semi-structured data, data that is not as strictly organized as structured data but still has some level of structure or organization, such as XML or JSON files. Unstructured data, data that lacks a specific format or organization, often consisting of text, images, audio, and video files. Big data, large, complex datasets that require advanced computational techniques for processing, analysis, and storage. Examples include social media data, sensor data, and scientific data. Information, in contrast, is data that has been processed, organized, and presented in a way that makes it meaningful and useful to the recipient. The transformation of data into information often involves filtering, aggregating, or analyzing the data to reveal patterns, trends, or relationships. In information technology, information is used to inform decision-making processes and support various tasks, such as problem-solving, planning, and communication. Information can be further classified into different types, including descriptive information, information that provides a basic understanding of a subject or situation, such as definitions, classifications, and descriptions. Diagnostic information, information that helps identify the causes of problems or issues, such as error messages or troubleshooting guides. Predictive information, information that forecasts future trends, events, or outcomes, such as weather forecasts or sales projections. Prescriptive information, information that offers guidance or recommendations for actions to take, such as best practices or operating procedures. Data transformation is the process of converting raw data into meaningful information. This process often involves several steps, including data collection, gathering data from various sources, such as databases, sensors, or user input. Data cleansing, identifying and correcting errors, inconsistencies, and inaccuracies in the data. Data integration, combining data from different sources and ensuring consistency and compatibility. Data analysis, applying statistical and computational methods to identify patterns, trends, and relationships in the data. Data visualization, presenting the processed data in an easily understandable format, such as charts, graphs, or tables. Data interpretation, drawing conclusions and insights from the analyzed and visualized data, often by relating it to the context and goals of a specific task or project. With a firm understanding of data and information, let's examine the key technical differences between these two concepts. Context. Data is raw and unprocessed, lacking context or meaning, while information results from processing and organizing data to provide context and meaning. Structure. Data can be unstructured, semi-structured, or structured, while information is typically structured and presented in an easily understandable format. Relevance. Data may or may not be relevant to a specific situation, whereas information is always relevant and directly applicable to the situation at hand. Usage. Data, in its raw form, is not directly useful for decision-making, while information is specifically designed to inform and guide decisions. Dependence. Information is derived from data, meaning that without data, there can be no information. However, data can exist independently of information. Understanding the technical differences between data and information is essential for making informed decisions, particularly in the fields of computer science and information technology. Accurate, relevant, and timely information is crucial for effective decision-making, as it enables organizations and individuals to identify problems and opportunities. By analyzing data, organizations can uncover issues that need to be addressed or areas with potential for growth and improvement. Evaluate alternatives. Information helps decision-makers compare the pros and cons of different options, allowing them to select the most effective course of action. Monitor performance. Regularly collecting and analyzing data enables organizations to track their progress toward goals and make adjustments as needed. Forecast future trends. Analyzing historical data can help organizations predict future trends, enabling them to plan and prepare for potential challenges and opportunities. Communicate effectively. Presenting information in a clear and concise manner is essential for effective communication, ensuring that all stakeholders understand the implications of the data and can take appropriate action. In conclusion, understanding the technical differences between data and information is crucial for anyone working in computer science or information technology. By recognizing these distinctions, you can better process, analyze, and utilize data, ultimately leading to more informed decisions and effective outcomes. We hope this comprehensive guide has provided you with valuable insights into the world of data and information. Don't forget to like, share, and subscribe to our channel for more in-depth explorations of tech topics. Thank you for watching, and we'll see you in the next video.